Okay, how to use Table C to obtain p-values when conducting hypothesis tests. So this is used when we have our test statistic from our hypothesis test, which is a t, if it equals x minus mu naught divided by s divided by square root n. So notice again we are using s, the sample standard deviation, instead of sigma, the population standard deviation. So this is when we use the t distribution, Table C, and let's say we have the t equals, in this case, let's say we calculate it and it turns out to be 2.697, let's say. Then we also need to know the size of the sample. Let's say n was equal to 10. Then we know that we would have 9 degrees of freedom. So we would look across this row for the value t equals 2.697, and we can see that it would fall in between these two values. So it would be between 2.398 and 2.821. And depending on whether it's a two-sided test or a one-sided test, we go to the bottom of the table to find the p-value. So if in fact it is a one-sided test, we take these two values because they correspond down the same column as the value where t would fall. So we can see that the p-value then would be between 0.01 and 0.02. So for a one-sided test, the p-value would be between 0.01 or 1% and 0.02. If it's a two-sided test, we would then see that it would be between 0.02 and 0.04. So two-sided p-value in this case would be between 0.02 and 0.04. So it's not like the standard normal distribution when we are using a test statistic that is z. Here rarely is it exactly equal to a value in our table. So we look at the value t and try to find it along the degrees of freedom, which is one less the size of our sample. In this case it's 9, and then we find where it would fall in between. So we can see it's between those two values. We just scroll down those two columns to find whether what the p-value is, dependent on whether it's a one-sided test or a two-sided test.